Hello and welcome everyone. I am Orko. If you are coming in this channel for the first time, so what we do here, we talk about quant topics that are most relevant for your CAT, NMAT, SNAP, IFT, basically any kind of India and MBA entrance exams. So today we will talk about a topic which is very important for your any entrance exams you write in mm, India for MBA, or even if you are doing non-MBA also. This is a very foundational topic and a very important topic. Over the years we have seen a couple of questions coming, up to three questions at a time coming in CAT. In few years CAT people have seen more than two questions from this topic. In NMAT SNAP IFT also, there are 3 to 4 questions you can expect out of this topic. So the topic is quadratic equation. So when I say quadratic equation, so if we remember in the last session, we talk about the simple linear equation where the maximum power of a variable in an equation is 1. Here we will talk about a quadratic equation where the maximum power of a variable is 2. So that's when it's called quadratic. So I'll go to the basics and in depth. So let's see what all we are going to cover in next some time in this chapter. So we'll talk about the basics of quadratic equation. What is a quadratic equation? How it is formed? Then we will talk about the graphical interpretation, which is very important. Very important when finding out the quadratic equation. You should have a graphical view so that you can understand well. So then we'll do the graphical interpretation, and then we try to understand the factors of quadratic equation, and I will explain you what it is, factors of quadratic equation. Then we'll do nature of factors and how the factors typically, what are the properties of the factors of a quadratic equation. Then we'll talk about inequalities of quadratic equation. So that's the next part that we are going to talk about. Then we'll talk about the discriminant and roots. And finally, we'll talk about the change in factors and adjustments. So these are the top 7 things we are intended to cover in today's session. But before that, without further ado, it's a little longer list, so the session may be a little longer, but let's get started. So what is a quadratic equation? A quadratic equation, like I said, will have the maximum power of the variable in the equation is 2. So the most generic form, of a quadratic equation is going to be ax square plus bx plus c equal to 0. This is the most generic form of a quadratic equation, right? Now, to satisfy the quadratic equation, it has to be a, b, c has to be real number, and a cannot be equal to 0. If a is equal to 0, your ax square value becomes 0. So then it will not remain a quadratic anymore, because the power of 2 where with the x has the coefficient which is 0. So that means it is making it 0. So ax square plus bx plus c, if in this equation, if a becomes 0, then it may not remain quadratic anymore, right? Now, this is the most fundamental part of quadratic equation. Okay, so with that, if you see, so what is equal here? So since highest power is 2, ax square plus bx plus c equal to 0, will have two roots, right? So since the highest power is 0, this equation will have two roots. So like we said in the linear equation, x can have one solution. Here x will have two solutions, or these solutions are called as roots. So a will have two roots. So how it is given in geometrically? So in geometric way, a quadratic equation takes a shape of a parabola. So what is the shape of a parabola? So it takes the shape of a, just a minute. So it takes the shape of a parabola, where you consider it's touching the x-axis here. Okay? So it takes the shape of a parabola. So this is the generic representation of any quadratic equation. Now with the value of a, b, c, it will change, but this is the generic. So one thing is, if a greater than 0, or the coefficient with x square is more than 1, then it becomes a upward inverted parabola, right? It becomes a upward inverted parabola. And if a less than 0, then it becomes a downward inverted parabola, right? So that's the main difference. So if a greater than 0, it becomes a upward parabola. If a less than 0, it becomes a downward parabola. So that's where a is basically the coefficient of x square. So how if x square is positive, it will become upward parabola. If x square is negative, it will become downward parabola. Let's make with an example. So let's say x square minus 10x plus 16 equal to 0. This is the equation. So how we solve normally a quadratic equation? So we take a product of the coefficient of these two and try to adjust the middle value according to this. So here it is 1 into 16. So the product is 16. Then I will try to adjust 10. Try to adjust 10 by addition or subtraction of two numbers whose product will be 1 into 16 or 16. So basically you have to break 10 into two numbers whose products will be 1 into 16 or 16. So that's the normal middle term breaking. If you have done in your school days, it's the same way. If you have not done, I'm just refreshing your mind. Is basically any quadratic equation solution, that's the most common way of solving it. So you have the coefficient of x square and constant term, you multiply the first and last term. Not first or last term. Think of this as a first coefficient of x square, which is 1, and the constant term, which is 16. You have to multiply, and then whatever be the value, you have to break the middle term or 10 here in such a way so that the sum or the whatever plus minus you write becomes 10 only, but there those two terms multiplication has to be equal to 16. So here I can break 10 into 8 and 2 so that it becomes the multiple becomes 16. So we can write x square minus 8x minus 2x plus 16 equal to 0. So this becomes x into x minus 8 minus 2, x minus 8 equal to 0. So we can write x minus 2 into x minus 8 equal to 0, or we can write x equal to 2 and x equal to 8. So these are the two roots. Remember, a quadratic equation will always have two roots. So now if we see, that means this equation, so this is your x-axis, this is your y-axis. So in this equation, x coefficient of x square is 1. So here I can say a is greater than 0 because a is 1. Now x is 2 and 8 means it will be an upward inverted parabola, but it will go through the point 2 and point 8. So the parabola will look like this, right? So this will be the graphical representation of your equation that we have given. Let's take another quick example. Let's do 3x square minus 10x plus 21 equal to 0, or we can write 3x square minus 3x minus 7x plus 21. Sorry, not 21. 21 will not cut. So let's say plus 7 equal to 0. So 3x square minus 3x minus 7x, because the multiplication here is 21, I have to break 10 into two numbers whose sum is, or difference is 10 and their product is 21. So that's why I break it in 3 and 7. So 3x, if you take x minus 1, minus 7 you take x, sorry, this is 7 only. X minus 1 equal to 0. So then I can write 3x minus 7 is 1, and x minus 1 equal to 0. Right? So from here I can write x equal to 1 and x equal to 7 by 3. So here also I see a is greater than 0 because a is 3. So your graph become, it has to pass through x1 and 7 by 3. So your graph become like this. This is 1 and this is 7 by 3. This is x-axis, this is y-axis. So that's how you draw the graph of a parabola, which should be symmetrical like this. So you can ignore this part. Okay. Now also one more important thing. These are called as the factor. These are called as the factors of the quadratic equation. So if I say alpha and beta are the factors of a quadratic equation, or alpha and beta not the factor, alpha and beta are the roots of a quadratic equation, then the factors will become x minus alpha into x minus beta, right? And how will you write the equation from here? So x minus alpha into x minus beta equal to 0, right? So when I say alpha and beta are the roots of the quadratic equation, you can write x minus alpha and x minus beta are the two factors, and x minus alpha into x minus beta becomes 0, right? So this is one way of writing from roots to factors if you know the roots. So let's say I am saying 5 and 7 minus 7 by 2 are, this is an example, 5 and minus 7 by 2 are two roots, find equation. So then I can write 5 and 7 by 2 are my two roots. So what will be my factors? My factors will be x minus 5 into x minus 7 by 2. So from here I can write x minus 5 x plus 7 by 2. If I do a square, x square plus 7x by 2 minus 5x plus 35 by 2, right? So minus 35 by 2. So you can go ahead and write it as, you can simplify this and get the one equation. So that's where we use roots. If you know the roots, how to write the equation from there. So that's another important thing you should remember when you are doing quadratic equation. Okay, so what we have covered till now. So if we just do a recap. Just a minute. Yeah. So we understand the basics. We understand the basic graphical interpretation. We understand the factors. And nature of factors we have not gone yet, so we will go there. But let's see inequalities. So this is, so basically in the first part we understand what is a quadratic equation and what is the absolute fundamental condition of being a quadratic equation is this two. And then we understand the graphical representation of a quadratic equation. And then we saw how to solve a quadratic equation, how to find out the factors, and from the factors how to find out the roots. So all these things we have understood till now. And if we understood if there are two roots are given, from the roots how to find out the factors, and once you find out the factors, how to find out the solutions of the quadratic equation or the equation of the quadratic equation. So now say that let's talk about the inequalities. So before doing inequalities, let's understand how it happens. So let's say ax square plus bx plus c equal to 0 has two roots, x equal to alpha and beta, right? Now if a is greater than 0, what is the kind of equation you will get? Say alpha and beta. So let's say this is alpha and this is beta. I don't know the value of alpha and beta. I take one on the negative side, one on the positive side, right? So it's alpha and beta. Now here, if you see, we can say this is same as y, which is equal to ax square plus bx plus c, right? So y, that's when, so the y value or the entire value of ax square plus bx plus c will be greater than 0 when uh, y is positive. Now when y is positive, uh, y is positive in this zone, right? Because this is on the top of the x-axis. When y is negative in this zone, when is below x-axis, but it has to be in the graph. So so y is positive. So if you see very carefully, what we are trying to say is, just a minute. So if you see this very carefully, what we're trying to say is y is positive when it is above the x-axis, when the graph is above x-axis, and y is negative when the graph is when the value is below x-axis. So that's basically where y is positive, where y is negative. Okay, but if you see this carefully, so the y is positive when it is going up above x-axis. So there is if you see the graph, the area above x-axis is infinite. So there is a lot of, if you see the graph is opening upwards. So the above x-axis, so above x-axis in this zone, above x-axis in this zones, typically y is positive because this side is above x-axis, and below x-axis the graph has only this section. The graph has only this section where it is negative. So then we can say y is greater than 0 when the value is left of alpha. So this part, so y is greater than 0. So when x is less than alpha and x is greater than beta, right? When x is less than alpha and x is greater than beta, and y is less than 0 when x lies between alpha and beta. So this is what you need to figure out, is basically when it's downward. So if see, this is the small section where y will be negative, and anything above x-axis y will be positive, right? So between alpha and beta is if it takes any value. So between alpha and beta, if it takes any value, so also you see it this way, between alpha and beta, right? Between alpha and beta, if x value takes 0, then for that corresponding x value, your y value will be somewhere here. Y value will be somewhere here, which is negative. But beyond alpha, again between alpha and beta, if x takes this point, your y value will be this point for this x. If y take this value, if x takes this value, then for that y will has to take this value, which is again negative. But beyond alpha and beta, to the left side of alpha, or when x is less than alpha, let's say x takes this value, so y can take this value, so y is positive. Similarly, right to the beta, if x takes this point, y will corresponding take this point, and again right to the beta, y is positive. So now you can understand why y is greater than 0 so when x is less than alpha and greater than beta, and y is less than 0 when alpha y is less than 0 when x lies between alpha and beta. Very similarly, if we have to say a is less than 0, then my graph, if you see typically, will become like this. Alpha and beta, this is x, this is y. Now, if you see carefully, I know y equal to x square plus bx plus c. So here, only in this region, I can say your y is positive. So y is greater than 0. Again, top of y-axis is where y is positive, y is greater than 0. Between when alpha, x, beta, and y is less than 0, if anything towards the left of alpha or to the right of beta. So to the left of alpha, if x takes this value, your y will be negative because this will be y value. If x takes this value, your y will still be negative because y has to take a negative value. So you can write x less than alpha, or the other way you can write is minus infinity less than x less than alpha, and x is greater than beta, or you can write beta less than x less than plus infinity. So these are the two ways you can write it. So let's take a small example. Let's take find x when let's say x square minus 7x plus 12 is less than 0. Find the value of x for which x square minus 7x plus 12 will be less than 0. So let us solve it. So we can see x square minus 7x plus 12 equal to 0. If we can factorize it, we'll see x minus 3 and x minus 4 will be equal to 0. Again, 12 into 1 is 12, and you break 7 into 3 and 4 like we did in the previous few minutes earlier. This will be your factors of this equation. Now, once you know the factors of this equation, you know what is your alpha. Your alpha is 3, your beta is 4, right? X minus 3 equal to 0 and x minus 4 equal to 0. So you know the alpha and beta. Now here x is positive. So if here x is positive, we will have this, sorry, not this, 3 and 4, right? So x is 3 and then x is 4. Let's not circle it. X is 3 and let's say x is 4. So your graph will go like this. Your graph will go like this, right? So between 3 and 4, your value of this equation will be negative. So 3 less than x less than 4 is when x square minus 7x plus 12 will be less than 0, right? So this is what you have to understood. So between 3 and 4, if you take any value, I'll show you the example also. If you take 3.5, if you put 3.5 in this equation for x, you will see the answer becoming negative. But if you take anything to the left of 3, let's say you take 0. If you take 0, the value of this equation becomes 12. 0 square minus 7 into 0 plus 12 is 12. And so that is become positive. Even if you take 10, which is right of beta or right of 4, you take 10 square minus 7 into 10 plus 12. This is 100 minus 70 plus 12, which is greater than 0. So you can see left of 3, right of 4, it's always greater than 0. Between 3 and 4, it's only when it is less than 0. So this is a very important understanding of how to do when, how to understand it graphically for the inequalities in quadratic equation, right? So this is one part of it. The other way of doing it is, if you see this, one thing I wrote here. So this is one part. So here in your equation 3 and 4. Now let's take another example and I will show you the other side. And a very important concept that needs to be covered is, let's say I said the same problem. I said x square minus 7x plus 12. X square minus 7x plus 12. In this case, I said less than 0. So in this case, let's say greater than 0, right? So we saw it will be greater than 0. When it will be greater than 0? When x is in the left of minus 3 and right of 4. So one way of writing this is x is less than 3 and x is greater than 4. Sometime if there you can also see an option like minus infinity less than x less than 3. So this is one part, which is, and it has to be uh, 4 less than x less than infinity. So these can be two solutions, right? So this can be two solutions. So this is, and this is one way of writing because this is a union sign. Now also understand one part. When I say x belongs to, and this is a belongs to sign, x belongs to, so 3 and 4, if I write this, that means 3 and 4 are not included, right? When you see both the first parentheses are given, that means 3 and 4 are not included. But if I write x belongs to 3 comma 4, that means 3 and 4 are included now, right? Now if I write where there is a third parenthesis, if I write 3 comma 4 where there is one third bracket or third parenthesis and the first parenthesis are there, then we can say 3 is included, 4 is not included. So this is a very important understanding, when it is included, when it is not included. And we'll do that more when we do the inequalities class. But just to give you an important understanding before we move on. Now, nature of roots. So let's see how to do that. So let's say ax square plus bx plus c equal to 0, and I say x has two roots, alpha, beta. Now from the two roots I can figure out this is the two factors, and from these two factors, by equating them with 0, I should get the same equation, right? If this equation has roots of x equal to alpha and beta, from by knowing x equal to alpha and beta, I can write the equation this way also. That means if I write x square minus alpha x minus beta x plus alpha beta equal to 0, means I can write x square minus alpha plus beta into x plus alpha beta equal to 0. So ideally, this equation and this equation should be same. So here I see in this equation x square has a as a coefficient, but here x square has 1 as a coefficient in this. So if this equation I divide by a, so then x square in this equation will also have 1 as a coefficient. So let's do that. So x square plus bx by a plus c by a equal to 0. Now this will be comparable with this equation. So can I say b by a is equal to minus of alpha plus beta, and c by a is equal to nothing but alpha beta. So right, so minus alpha plus beta. So we can write sum of roots is equal to b by a, and product of roots is equal to c by a. So if you have ax square plus bx plus c equal to 0, this is a very, very important understanding. So a lot of time they will give you two roots, and from there they will ask you to form the equation. Or they might tell you sum of roots, they might tell you product of roots, not giving you the two roots right away. So how to find out the equation? And so the equation will become x square minus, so sum of roots, this is not minus, this is only alpha plus beta, plus product of roots, this equal to 0. So this is a very important understanding. So x square minus sum of roots into x plus product of roots equal to 0. So let's say I say there is a there is an equation for which, let's say, sum of root is 12 and product of root is, let's say, 32, right? So you have to find the equation. So equation will be x square minus 12x plus 32 equal to 0. That's how you find out the if you know the sum of roots and the product of the roots, that's when you find out the equation like this. So this is one important piece which you need to understand, is how to use the sum and product of the roots. So that's one. I think what is more important for you to understand is how these roots typically behave. So change in roots, and this is one of the most critical part. You see a lot of problem using this. So ax square, whatever we are covering here now, this is a way, all of these are very, very important concepts. So anywhere you find it difficult, please drop me a note in the comment section, or you can mail me. We can arrange a session if you need more help. But you can comment me also if anywhere you are stuck, we'll be able to respond. So x square plus bx plus c equal to 0, and let's say x has two roots, alpha and beta, right? Now, if alpha and beta are the two roots, then normally your factors become x minus alpha and x minus beta. So this is one part. But let's say in first case, let's say your root become from alpha and beta, it become alpha plus k and beta plus k. Sorry, beta plus k. Right? So your roots are changed. So then what will be your equation? Your equation become a into x minus k whole square, b into x minus k plus c equal to 0. Right? In the second case, let's the root become alpha minus k, comma beta minus k. Your equation will become a into x plus k whole square, b into x plus k plus c equal to 0. Third case, let's say the root is getting multiplied with alpha k, root become alpha k and beta k. Then your equation become a into x by k whole square, b into x by k whole square, b into x by k plus c equal to 0. So whatever happens to the root, you do the reverse to the equation where x is. You just adjust x with the reverse one. So if k is multiplied with the roots, you make x divided by k. If k is subtracted to the roots, you just made the equation by adding k to x. Similarly, if it is alpha by k and beta by k at the roots, then it will become a into xk whole square, b into xk plus c equal to 0. Similarly, if you say, and this is one very important thing, if roots become 1 by alpha and 1 by beta, then your equation become cx square plus bx plus a equal to 0. Very, very important one. This one you can put a star. This is a very important one. When the roots becomes the reciprocals, how your equation changes. What we see when it becomes reciprocal, you c and a interchange their position, right? The other one, say, if it becoming square, alpha square, beta square, so basically the roots are becoming square. You can say a into root x whole square, b into root x plus c equal to 0. If it becoming cube, then it will be cube root of x whole square, b into cube root of x plus c. So that also you can do. But if it is square or cube, the same square nth root of that will become in x. So if alpha to the power 4, beta to the power 4, then a into fourth root of x whole square plus b into fourth root of x plus c equal to 0. So that way you can adjust. But this is a very important list, specifically the fifth one. We solve a lot of problem in the next session when we come to the problem sessions. This is a concept session. We are not typically diving into too many problems where we see multiple type of problem. We are just taking problems where your concept needs to be clear, and that's about it. But we will do a dedicated 2 session, first session on foundational level problem and second session on a deep dive problem. We will do that, and we'll solve all the type of problem that the concepts we are talking. So first, in this session, understand the conceptual clarity completely. Any doubt in the concepts, please let me know. Right now, let's take typically the last part before we wrap. Quadratic equation is the discriminant. Now, what is a discriminant? Now, ax square plus bx plus c equal to 0 is, this is a generic equation. The generic solution, no matter whether you do middle term or you do anything. So if I give you some random term, let's say x square minus 5x plus 2 equal to 0, it's basically difficult to do it through middle term breaking or the approach that we have given. So irrespective of any quadratic equation, the generic solution will be x equal to minus b plus minus root over b square minus 4ac into it. There is a solution to it completely. How? From here we do it by dividing by a, doing forcefully square, and these things. But we are not going into too deep. You don't need to know the approach of the solution, but you can understand. You can remember this is the generic solution of any quadratic equation, right? Minus b plus minus root over b square minus 4ac by 2a. Now, the thing is, so you can see there are two roots. One root is minus b plus root over b square minus 4ac by 2a, and the other root is minus b minus root over b square minus 4ac by 2a. So these are the, this is root 1, this is root 2. So these are the two roots of the quadratic equation. Now minus b and minus 2 are very generic, but depending on the nature of b square minus 4ac, since it is under root, the nature of the roots changes. So b square minus 4ac is called as discriminant. It is a very powerful piece. It can changes the nature of the root, and we will see how. This is denoted as d. Okay, move on. So I'll just write d is equal to b square minus 4ac just for your reference, and x equal to minus b root over b square minus 4ac by 2a. Now there is a chance that discriminant is equal to 0. If the discriminant is equal to 0, that means your x is minus b plus minus root over 0 by 2a or minus b by 2a, right? So, but it has to be a quadratic equation. So that means it will have two roots, but two equal roots. So discriminant equal to 0, you have two equal roots, and both the roots are x is equal to minus b by 2a. So this is your root. So how to present in a graph? It will be 1 point. It will be cutting x-axis. It will be just touching x-axis. Previously, we have seen there are graphs like this where there are two solutions, but here we have one value but two roots. So that means it will be just touching the x-axis. That's the root. That's the nature of when d equal to 0. Okay. Now let's move on. If I say d is greater than 0, that means I can say b square minus 4ac is greater than 0, or x equal to minus b plus minus root over b square minus 4ac by 2a. This is the equation. So the thing under the root, is greater than 0. So in that case, roots are unequal. Roots are unequal, right? Roots are unequal. Because one will be minus b plus root over b square minus 4ac, and minus b minus root over b square minus 4ac. So these are roots are unequal. Now, unequal and real. Okay, real. Why I say real? I'll come to that. Now, if I say d is greater than 0 and d is perfect square, If d is perfect square, that means the thing that is under the root b square minus 4ac a full square. So that means we won't have any root over under that. So if we have 25, that root over sign will completely go because root over 25 is 5. But if we have 27 as d, so that means b square minus 4ac is 27. So root 27 will not completely do away with the root over. So if you recall the rational and irrational number, if b square minus 4ac is not a perfect square, you will have root in the number. So if d is a perfect square, roots are real, unequal, and most importantly, rational. Rational because your root over sign will go if it is a perfect square. If d is not a perfect square, your roots are real, unequal, but irrational because the root is not 1. So we call the rational irrational number. If the root is completely solved, or if any number cannot be written as p by q, where p and q both are integer, then that time it should be considered as a irrational number. In simple equation class, we have given it in depth what is rational, irrational, and how to find it out. You can refer to that class. We'll drop a note. But this will become a irrational because you will not be able to completely get away with the root over sign. Right? Now the last part, if d is less than 0. If d is less than 0, x is equal to minus b plus minus root over b square minus 4ac by 2a. So we will have, if b square minus 4ac is less than 0, that means you will have a negative sign under root. So then roots are non-real or imaginary. How to write imaginary roots? So imaginary root will, so basically you will have root over of minus negative minus 3, let's say. So this is become a imaginary root because you can't have negative sign under root. So to do that, we introduce because imaginary, it will have a complex number. So it will be a complex number. Complex number is represented typically with I, where I is root over of minus 1, and we say I square is minus 1, and I to the power 4 is 1. So I is represented as minus 1. So minus 3 go, we can write it as minus 3. So root over of minus 1 into 3, and or root 3. And then we can write this minus root over of minus 1 as I, or we can write root 3i. So this is the way we can write something under root by introducing a complex number I. Okay. So there are few rules of root over. So then roots are non-real and imaginary. So what will happen if d is less than 0? So roots will be imaginary. And when I say imaginary or complex, both are same. Imaginary roots always in pairs. So it will never happen that one root of the number is imaginary and the other root is non-imaginary. So the normal way in pairs. And so if one root is a plus ib, other root will be not roots, other root will be a minus ib. So if you see typically from here, we can say minus b plus I a IC, let's say, by 2a, and the other one is minus b minus IC by 2a. So just taking C as a outcome of b square minus 4ac. So roots will always occur in pairs, and this will be the pair. So if one is a plus ib, the other one will be a minus ib. So these are the two or three very important formula of imaginary roots. So it will, like I said, it will never happen that one number is imaginary, one root is imaginary, the other root is not imaginary. So both of the roots has to be imaginary or complex numbers when d is less than 0. So this is it. I think we have covered quite a few in quadratic equation. If you have any doubts, please drop a note. We will do a detailed session on problems, couple of detailed session on problems, where we see from basic problem to the most advanced level problem. We'll cover everything. So we've had a good session. See you next time. Thank you. Bye.